In the present lecture, we will discuss the example problem on principle of dominance rule. Let's see the problem. Using the principle of dominance, solve the following game. Here, player A having the 5 strategies and player B having the 6 strategies. Let's see the solution. Before applying the dominance rule, we should have to check the saddle point of the game by applying the Maximin and Minimax principle. So first we have to determine the Maximin value. For this, first we have to determine the minimum values for the each row. For the first row, minimum value is the 0. In the second row, minimum value is the 1. And in the third row, minimum value is the -5. In the fourth row, minimum value is the -1. And in the fifth row, minimum value is the -2. Next, we should have to select the maximum value among these minimum values, that is we are calling as the Maximin value. Here maximum value among the minimum values of 0, 1, -1, -1 and 2 is the 1. So 1 is the maximum value. So this one we are calling as the Maximin value. Similarly, next we have to determine the minimax value. For this, first we have to identify the maximum values for the each column. For the first column, maximum value is the 4. In the second column, maximum value is the 3. Third column, maximum value is the 7. Fourth column, maximum value is the 3. Fifth column, maximum value is the 2. For the sixth column, maximum value is the 2. So next we have to select the minimum value among these maximum values, that is we are calling as the minimax value. So here minimum value among these maximum values of 4, 3, 7, 3, 2 and 2. Among these maximum values, minimum value is the 2. So 2 we are calling as the minimax value. So here minimax value is the 2 and maximin value is the 1. So minimax is not equal to the maximin. So the given payoff matrix does not having any saddle point. So then we have to apply the principle of dominance to reduce the size of the payoff matrix by deleting those strategies which are dominated by others. First, to apply the dominance rule for the rows. By applying the dominance rule, each row is compared with another row, and if all the elements in a row should be less than or equal to the corresponding elements of the another row, then delete the row. Let's consider row X is compared with the row Y. If all the elements in a row X should be less than or equal to the corresponding element of the another row, that is Yth row, then delete the row X. So before applying the dominance rule, first we have to determine the total of each row elements. For the first row, row total is the 4 plus 2 plus 0 plus 2 plus 1 plus 1. So first row total is the 10. Similarly, second row total is the 15. Third row total is the 12. Fourth row total is the 14. And fifth row total is the 12. So now select the row based on this total value. So first to select the row 1 because its row total is minimum value. And first row is compared with the maximum value of the row total, that is the second row. So now we have to compare each element of the first row corresponding elements of the second row. So here 4 equal to the 4 and 2 is less than the 3, 0 is less than the 1, 2 is less than the 3, 1 is less than 2 and 1 is less than 2. So here in the payoff matrix, all the elements in the first row are less than or equal to the corresponding elements in the second row. Therefore, row 1 is dominated by the second row. Then we have to delete the first row. Next, apply the dominance rule for the third row and compare the corresponding elements with the second row elements. That is 4 equal to the 4 and 3 equal to the 3, but 7 is not less than and not equal to the 1. So here dominance rule is not satisfying. So next to compare this third row elements with the fourth row elements. That is, so 4 equal to the 4 and 3 equal to the 3, but 7 is not equal to the 4, moreover it is not less than the 4. So here also dominance rule is not satisfying. So next to compare the third row elements with the fifth row, that is 4 equal to the 4 and 3 equal to 3, but 7 is not less than and not equal to the 3. So here also dominance rule is not satisfying. Then dominance rule is not applied for the third row and we have to skip this row. Next, apply the dominance rule for the fifth row and compare the corresponding elements with the second row elements. So that is 4 equal to the 4 and 3 equal to the 3, but 3 is not equal to the 1, moreover not less than the 1. So here dominance rule is not satisfying. Then compare this fifth row elements with the fourth row. So here 4 equal to the 4 and 3 equal to the 3 and 3 is less than the 4, minus 2 is less than the minus 1 and 1 is less than the 2 and 2 equal to the 2. So in the given payoff matrix, all the elements in the fifth row are less than or equal to the corresponding elements in the fourth row. Therefore, row 5 is dominated by the fourth row. Then you have to delete the fifth row. Next, apply the dominance rule for the fourth and second rows. First, apply the dominance rule for the fourth row and compare the fourth row elements with the second row and third row elements. First, compare the fourth row elements with the second row elements, that is 4 equal to the 4 and 3 equal to the 3, but 4 is not less than the 1 and moreover 4 is not equal to the 1. So here dominance rule is not satisfying. Then compare the fourth row elements with the third row elements, that is 4 equal to the 4, 3 equal to the 3, 4 is less than the 7, but minus 7 is not less than the minus 5 and moreover minus 1 is not equal to the minus 5. So here also dominance rule is not satisfying. Then we can't apply the dominance rule for the fourth row. We have to skip the fourth row. Next, apply the dominance rule for the second row and compare the second row elements with the third row and the fourth row. So first we have to compare the second row elements with the third row elements, that is 4 equal to 4, 3 equal to 3, 1 is less than the 7, but 3 is not less than the minus 1, moreover 3 is not equal to the minus 5. So here dominance rule is not satisfying. Then compare the second row elements with the fourth row elements. That is 4 equal to the 4, 3 equal to the 3, 1 is less than the 4, but 3 is not less than the minus 1. Moreover, 3 is not equal to the minus 1. So here also dominance rule is not applying. So dominance rule is not applying for the second row also. So by applying the dominance rule for the rows, we deleted the 2 rows, that is 2 strategies for the player A. Next, to apply the dominance rule for the columns. By applying the dominance rule, each column is compared with the another column, and if all the elements in a column should be greater than or equal to the corresponding elements of the another column, then delete the respected column. Let us consider column X is compared with the column Y, and if all the elements in a X column should be greater than or equal to the corresponding elements of the another Y column, then we have to delete the X column. So before applying the dominance rule, we have to determine the total of the each column elements. For the first column, total of the all the elements is 4 plus 4 plus 4, 12. For the second column, total is the 9. For the third column, total is the 12. For the fourth column, total is the minus 3. Fifth column, total is the 5. Similarly, for the sixth column, total is the 6. Now select the column based on this total value. So first we have to select the column 1 because its column total is maximum value, and this first column is compared with the fourth column because its total is the minimum value. Let's compare the first column with the fourth column. So 4 is greater than the 3, and 4 is greater than the minus 5, and 4 is greater than the minus 1. So in the given payoff matrix, all the elements in the first column are greater than the corresponding elements in the fourth column. Therefore, column 1 is dominated to the fourth column. Then I have to delete the first column. So next apply the dominance rule for the third column and compare the corresponding elements with the fourth column. That is, 1 is not greater than the 3, moreover 1 is not equal to the 3. So here dominance rule is not satisfying. So next to compare this third column with the another column, that is the fifth column. So because next to minimum value is for the fifth column. So compare the third column with the fifth column, that is 1 is not greater than the 2 and also 1 is not equal to the 2. So here also dominance rule is not satisfying. So next we have to compare this third column with the sixth column because next to minimum value is for the sixth column. So compare the third column elements with the sixth column elements. Same here also 1 is not greater than the 2, moreover 1 is not equal to the 2. So here also dominance rule is not satisfying. So next to compare the third column with the second column elements because next to minimum value for the second column. So here also 1 is not greater than the 3. So here also dominance rule is not satisfied. So moreover dominance rule is not applicable for the third column. So we have to skip the third column. So next we have to move the dominance rule for the another column, that is the second column. So now compare the second column with the another columns. First we have to compare the second column with the fourth column because minimum values for the fourth column. So here 3 equal to the 3 and 3 is greater than the minus 5 and 3 is greater than the minus 1. So here in the given payoff matrix, all the elements in the second column are greater than or equal to the corresponding elements in the fourth column. Therefore, second column is dominated to the fourth column, then you have to delete the second column. So next apply the dominance rule for the sixth column and compare the corresponding elements with the fourth column. So here 2 is not greater than the 3 and moreover 2 is not greater than the 3. So next we have to compare the sixth column elements with the fifth column elements, because next minimum value is the 5 for the fifth column. So here 2 equal to the 2 and 2 is greater than the 1 and 2 equal to the 2. So all the elements in the sixth column are greater than or equal to the corresponding elements of the fifth column. Therefore, sixth column is dominated to the fifth column. Then we have to delete this sixth column. Next apply the dominance rule for the fourth column and the fifth columns. First apply the dominance rule for the fifth column and compare the fifth column elements with the fourth column as well as the third column. So first we have to compare the fifth column elements with the fourth column elements. That is 2 is not equal to the 3 and moreover 2 is not greater than the 3. So here dominance rule is not satisfying. Then you have to compare the fifth column elements with the third column elements. That is 2 is greater than the 1 but 1 is not greater than the 7 and not equal to the 7. So here also dominance rule is not satisfying. So we can't apply the dominance rule for the fifth column. So then we have to skip this fifth column. Next we have to apply the dominance rule for the fourth column and compare the fourth column elements with the fifth column and the third column. So first compare the fourth column elements with the fifth column. So here 3 is greater than the 2 but minus 5 is not greater than and not equal to the 1. So here dominance rule is not satisfying. Then we have to compare the fourth column elements with the third column elements. Here 3 is greater than the 1 but minus 5 is not equal and not greater than the 7. So here also dominance rule is not satisfying. Then we have to skip this fourth column. So by applying the dominance rule for the columns, here we are deleted the 3 columns, that is the 3 strategies for the player B. By applying the dominance rule, we reduced the payoff matrix is 3 by 3 matrix. For further reduction, no row or column is dominates to another row or column. In this condition, take the average of any 2 rows or columns and compare with the row or column. So first we have to compare the second row elements with the average of third and fourth rows. So second row elements are the 1, 3, 2 and average of the third row and fourth row elements are 7 plus 4, that is 11 by 2, 5.5. So minus 5 minus 1 divided by 2, that is the minus 3. 1 plus 2 divided by 2, so 1.5. So compare the second row elements 1, 3, 2 with the average values of the third and fourth row values, that is 5.5, minus 3 and 1.5. Here 1 is less than the 5.5 but 3 is not equal to the minus 3 and not less than the minus 3. So here dominance rule is not satisfying. Then you have to compare the third row elements with the average of the second row and fourth row elements. So third row elements are the 7, minus 5 and 1, and average values of the second row and fourth row elements are the 2.5, 1 and the 2. So here 7 is not less than the 7.5 and also it is not equal to the 2.5. So here dominance rule is not satisfying. Then compare the fourth row elements with the average of the third row and the second row elements. So fourth row elements are the 4, minus 1 and 2, and average values of the third row and second row elements are the 7 plus 1 divided by 2, 4, and minus 5 plus 3 divided by 2, it is the minus 1, 1 plus 2 divided by it is the 1.5. Then compare the fourth row elements with the average values of the third row and second row, that is 4 equal to the 4 and minus 1 equal to the minus 1, and 2 is not less than and not equal to the 1.5. So here also dominance rule is not satisfying. So next we have to compare the third column elements with the average values of the fourth and fifth column elements. Third column elements are the 1, 7, 4, and fourth and fifth column average values are the 2.5, minus 1 and 0.5. Here I have to compare. So 1 is not greater than and not equal to the 2.5. So here dominance rule is not satisfying. Then I have to compare the fourth column elements with the third and fifth column elements. So fourth column elements are the 3, minus 5, minus 1, and average of the third and fifth column elements are the 1.5, 4 and 3. So here 3 is greater than the 1.5, but minus 5 is not greater than or not equal to the 4. So here also dominance rule is not satisfying. Then compare the fifth column elements with the average of the third and fourth column elements. So fifth column elements are the 2, 1, 2, and average of the third and fourth column elements are the 2, 1 and 1.5. So here 2 equal to the 2 and 1 equal to the 1, and 2 is greater than the 1.5. So in the payoff matrix, all the elements in the fifth column are greater than or equal to the corresponding elements of the average of third and fourth column elements. Therefore, fifth column is dominated to the average of third and fourth columns. So here we have to delete the fifth column. By applying the dominance rule, we are reduced the payoff matrix size is 3 by 2 payoff matrix, that is player A having the 3 strategies and player B having the 2 strategies. So this 3 by 2 payoff matrix can be solved by applying the graphical method. So let Y is the probability of selection of strategy 3 by player B, and 1 minus Y is the probability of selection of strategy 4 by the player B. So Y and 1 minus Y. So probability of selection of the third strategy by the player B is the Y, and the probability of selection of fourth strategy by the player B is the 1 minus Y. So next to derive the expected gain function of player B with respect to each of the alternative of player A. For this one, draw the tabular column and here write down the player A strategies, that is the 2, 3, 4, and write down the payoff function in the terms of the Y and 1 minus Y. For this one, you have to multiply the 1 into Y plus 3 into 1 minus Y. So 3 into 1 minus Y plus 1 into Y. So that is the Y plus 3 minus 3Y. That is the 3 minus 2Y. So next we have to find out the gain values and considering the y equal to 0 and y equal to 1. So substitute the y equal to 0 in the expected payoff function, that is the 3 minus 2 into 0, that is the 3. Similarly substitute the y equal to 1 in the 3 minus 2y equation, we will get the, so gain value is the 1. So next B's expected payoff function is 7 into y plus minus 5 into 1 minus y, that is the minus 5 plus 12y. So then I have to substitute y equal to 0, then we will get the gain value is the minus 5, and substitute the y equal to 1, then gain value is the 7. So next to determine the expected payoff function, that is the for fourth strategy. So 4 into y plus minus 1 into 1 minus y, that is the minus y plus 5y. Then substitute y equal to 0, then gain value is the minus 1, and substitute y equal to 1, then gain value is the 4. So next to plot the gain function on a graph by assuming a suitable scale. Here keep the y values on the x-axis and gain values on the y-axis. Here y values are the 0 and 1. So first we have to draw the y values on the x-axis, that is y equal to 0 to 1. So next we have to mark the gain values on the x-axis. Here gain values ranges are the, for the positive side 7 and the negative side is the minus 5. So mark the gain values on the y-axis within the ranges of 1 to 7 in the positive side and minus 1 to minus 5 in the negative side. So next to mark the gain values for the second strategy. Gain values are the 3 and 1. So when the y equal to the 0, so gain value is the 3, and when the y equal to 1, gain value is the 1. So mark the 3 and 1. So 3 equal to the, so 3 value is when y equal to the 0 and 1 value is when y equal to 1. So then join these two values by the line. So this is the line for the second strategy. So next to mark the minus 5 and 7 for the third strategy. So minus 5 is when y equal to 0. Then mark the minus 5 when y equal to the 0. Similarly mark the 7 when y equal to the 1. Then join these 2 points by the line. This line is the for the third strategy. So next to mark the values minus 1 and 4 for the fourth strategy, and y equal to 0, gain value is the minus 1, and y equal to 1, gain value is the 4. So mark the minus 1 and the 4 and join these 2 points by the line. So this line is for the fourth strategy. So next to find the lowest intersection point in the upper boundary of the graph, that is we are calling as the mini-max point. So this is the upper boundary of the each respected line, and intersection points are the, so these are the intersection points. So these are all the intersection points. So this is the intersection points in the upper boundary. So in this one, in the upper boundary, we have to mark the, so lowest intersection point. So this is the lowest intersection point, and this point we are calling as the mini-max point. And observe the number of lines passing through this mini-max point. If the number of lines passing through this mini-max point is only 2, then we have to form a 2 by 2 payoff matrix. there are more than 2 lines are passing through the minimax point, there are the tie for the optimum mixed strategies for the player A. In this condition, any two such lines with opposite sign slope will define an alternative of optimum for A. So here observe at the minimax point, so 3 lines are passing. Then you have to select any 2 lines with opposite sign of the slope here. So you have to consider the second line strategy. So for the second line strategy, third and fourth are having the opposite sign slope. So we can be consider the 2 and 4th strategy, or maybe 2 and 3 strategy. So here we are considering for the strategies for the player A is 2 and 3. If you consider the 2 and 4 also correct one, but in this problem I am considering the strategies for the player A is 2 and 3. Now pair matrix is the 2 by 2 matrix, that is player A having the 2 strategies, second and third. Similarly player B also having the 2 strategies, that is the 3 and 4. And let's consider the P1 and P2 are the probability of selection of second and third strategies for the player A, and Q1 Q2 are the probability for the selection of third and fourth strategies for the player B. So we know these formulas to find out the probabilities of the P1 and P2, similarly Q1 and Q2. Similarly we know this formula for the value of the game. So let's consider here 1 is the A11 and value 3 is the A12 and value 7 is the A21 and value -5 is the A22, and substitute these values in the above equations. We will get the P1 is the 6 by 7, then P2 will become 1 minus 6 by 7, that is the 1 by 7. Similarly substitute these values in the Q1 equation. We will get the Q1 is the 4 by 7, Q2 is the 3 by 7, and V is the value of the game is the 13 by 7. Then the optimal strategy for the player A is 0 and 6 by 7 and 1 by 7 and 0, 0. Similarly for the optimal strategy for the player B is the 0, 0, 4 by 7, 3 by 7, 0. So this is the solution, and thank you.